All right. As we talked about on Tuesday, to be successful in trigonometry, you need to have a basic understanding of algebra and geometry. So on Tuesday, we talked about some of the geometric principles you got to know, the Pythagorean theorem. You got to know special right triangles, how many angle or what the sum of the angles in a triangle are. That's 180. Two angles are complementary. That means they add up to be 90. And angles that are supplementary add up to be 180. Those basic ideas. Today, we're going to talk about some of the basic algebra you have to be successful in trigonometry. So if you haven't yet, I need you to get out something with which to write and something on which to write, because I am going to ask you to do a few things and write a few things down. All right? Well, good news. We're going to start the algebra in a very easy spot, and it should almost be laughable how easy it is. But the first thing I want you to do is I want you to draw a coordinate plane like this. A coordinate plane, or a Cartesian coordinate plane, named after the guy René Descartes, he's the one who came up with it, is an x and y coordinate rectangular plane. And you always graph the x first. You go right or left based on x and up or down based on y. And so what I want you to do is I want you to draw a coordinate plane similar to what I have here. And I would like you to graph the points A, B, C, and D. So we can pause the video right here. Probably it'll take you maybe just a minute total. And everybody's going to graph all four of these points. And then we will check them and take a look at them. All right, so you can pause it right now. All right, and we're back. Okay, so we're going to graph A, B, C, and D, and these are real simple, okay? So if I was going to graph point A, now you notice I don't have any tick marks on here, but you can easily draw that. And so it says A is 5, 9. So I would just go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 5, 9 would be then right about here, and that would be point A. Okay, if I want point B, it says -4, 2. So I'm going to go 1, 2, 3, 4. I try to be relatively consistent. 2, 1, 2. Okay, and so that's going to be right here, and so that's the point B. C is at 8, -3. So I got 1, 2, 3, 4, 5, 6, 7, 8. -3 is going to be down 1, 2, 3, because we're doing about 2 for every line of paper we got. Okay, and so that's going to be point C right there. And point D, -1, -6. You go back 1 and then -6. 1, 2, 3, 4, 5, 6. So that's going to be right about there. That's point D. And so hopefully that's what yours looks like. Okay, everyone in here should be able to find points on the coordinate plane. And if I was to ask you what quadrant is A in, well, A is in the first quadrant. Okay, that's the first quadrant. It's always done in Roman numerals. B is in the second quadrant. D is in the third quadrant. And C is in the fourth quadrant. Okay. All right, next on our list is we got to talk about distance formula. Now, good news, we did distance formula this last semester, and so you should be pretty familiar with it, just like you should be very familiar with the coordinate plane. We did lots dealing with that. But if we did do distance formula, I went ahead and wrote it out right here for you. The distance formula is always referring to if you had 2 points that you're trying to find the distance in between those points. Like here, I could have the points like -7, 2. That'll be one of my points. And the other point will be 3, 8. And those will be my 2 points. -7, 2, and 3, 8. Okay, remember these are always x, y, x, y. It's always alphabetical order. All right, so if I was trying to find the distance between those 2 points, what I have to do, as you can see, is I've got to subtract the x's from each other, and then I take the result and square it. I subtract the y's from each other, take the result and square it. Then I add those up, and then finally I take the square root. So let's talk about how to do that with this one right here. Okay, and I'd love for you to follow along. So the distance between these 2 points would be equal to the square root of -7 minus 3. I'm going to square those when I'm done, plus, let's see here, 2 minus 8. Now, it doesn't matter what order you subtract them in. If you change the order, if I change the order of -7 and 3, the only thing that would do is change the sign of the difference of those two. And so it doesn't matter what order I subtract them in, because then even if it was positive or negative, it doesn't matter because I'm going to square it, and that's going to make it become positive anyway. Make sure you remember that. When you square a number, you're always going to get something positive. That's important. Okay, so here we go. So we're gonna go ahead and try these right here. And so we'll go, okay, negative 7 minus 3 is gonna be negative 10. I'm gonna square that. Plus 2 minus 8 is gonna be negative 6. I'm gonna square that. Negative 10 squared is 100. Negative 6 squared is 36. So the distance between these 2 points is 136. And it's that simple. All right? Easy. We've done this before. It's easy to do. So now what I'm going to have you do is I'm going to have you do a problem involving distance formula. This will be our first example. So we'll call it exemple numero uno. Okay, and what I want you to do is I'm going to give you 3 points. First, I'll give you point A, and A will be 1, negative 5. Give you point B. B is going to be 4, 10. And then I'll give you point C, and we'll call C will be negative 2, 3. And what my question is, so obviously we have these 3 points floating in space. We got A, B, and C. So A, B, oof, that's an ugly B, B, and C. And my question is, which one is closer to C? Is A closer to C, or is B closer to C? Which one is closer? And that's what I'm asking you to figure out. So you're going to have to find the distance between these 2 points and find the distance between these 2 points, and then compare those distances. So again, we're going to pause the video. This will probably take you, I don't know, I guess about 3 or 4 minutes to go ahead and find the answer. So go ahead and pause the video here, and then we can go from there. All right? Okay, and we're back. All right. Now, one of the things I noticed that maybe some of you did notice, on the last problem, we ended with an answer, square root of 136. And really, I should have simplified that because square root of 136 is the same thing as the square root of, what, 4 times 34? And the 4 could come out, and so that would be 2 times the square root of 34. I want to have us be in a habit of trying to simplify radicals as best we can. That may not have bothered you, but it bothered me as I looked back. Okay? All right, now let's talk about this example number 1. All right, let me get rid of all this right here. Okay, and so example number 1, let's do this. All right, so first I'm going to find the distance between A and C. So the distance between A and C, and I could use a little sub-notation like that, is going to be equal to the square root of, I'm going to say 1 minus a negative 2 squared plus negative 5 minus 3 squared. Okay, and what's that going to equal? Well, 1 minus a negative 2 is like 1 plus 2. So that's going to be 3. So I got 3 squared plus negative 5 minus 3 is going to be negative 8 squared. And so then I'm going to get 3 squared is going to be 9. Negative 8 squared is going to be 64. And so then 9 plus 64 gives me 73. So the distance from A to C is the square root of 73. Now, that's not a pretty number, but that's the answer. Okay? All right, now let's look for the distance from B to C. So the distance from B to C is going to be equal to the square root of, see, the distance from B to C. Well, I got to go 4 minus a negative 2 plus 10 minus 3. All right, remember, I always subtract the x from the x, square it, subtract the y from the y, square it, and then you add. Okay, so it's going to be equal to the square root of 4 minus negative 2 is like 4 plus 2, so it's going to be 6 squared, plus 10 minus 3 is 7 squared. So 6 squared is 36, and 7 squared is 49, and so 36 plus 49 is going to give me 85, and so this is equal to the square root of 85. So the distance from A to C is equal to the square root of 73. The distance from B to C is equal to the square root of 85. So which one is closer? Well, A is closer to C. Which one's further away? Well, B is a little bit further away. Even though I don't know what the square root of 73 is, and I don't know what the square root of 85 is, 85 is a bigger number, so therefore the square root would be a bigger number. Okay? Pretty simple. All right, so that's all of the algebra we're going to review. We need you to know coordinate plane, and we need you to know how to find the distance. All right, now what we're going to do is we're going to touch on a few new concepts. And so these are going to be important that you write down. There's not very many of them. We're going to keep this brief, but we got to talk about these new concepts. All right, concept number 1, write this down. We're going to talk about what in the world the unit circle is, okay? What is a unit circle? And a unit circle is simply a circle with radius 1. Oof, man, this is getting pretty sloppy. Sorry about that. I know this isn't very neat. But it's a unit circle is a circle with radius 1 of 1 that is centered at the origin. That's what a unit circle is. Now, later in this year, we're going to do a lot more with the unit circle. But right now, we just need this basic understanding of what the unit circle is. A unit circle is a circle with a radius of 1 that is centered at the origin. So what does that mean? Well, I could just draw a circle like this and say, okay, there we go. And we'll say that this is 1. Oops, it wants to move. There we go. We'll say that this right here is 1. This is -1. This is +1. That's -1. Okay? And so that right there is a circle with a radius of 1. The radius, right here, the radius is equal to 1. And so that's a unit circle. It's a really simple thing. Someone says, what's a unit circle? Say, well, a unit circle is a circle with a radius of 1 that's centered at the origin. Now, I'm not sure if anybody remembers, but we did circle problems, and we talked about what the equation of a circle was. And the equation of a circle was always x squared plus y squared equals r squared. If it was centered at the origin, it was x squared plus y squared equals r squared. And so because this one is centered at the origin, and because the radius is 1, we can plug that in right here, and we know that the formula for this is going to be x squared plus y squared equals 1. 1 squared is just 1, okay? There you have it. All right, so new concept for today, unit circle. Unit circle is a circle with a radius of 1 that's centered at the origin, and the coordinates will always fit into this. Now let's see here. We have... All right, this was actually example number 2 as I look back, because we could say example number 1 was filling out where the points are. So this is example number 2. That's why I'm getting to example number 3. So we kind of skipping around. I apologize. But so for example number 3, what we're going to do is you're going to check to see or to verify that the point square root of 7 over 4 and -3/4. This is a point. It's an ugly point, but that's a point. Those are the coordinates of a point. And what I want to do is I want to verify that this point is on the unit circle. Okay? So how do we do that? How do we verify that that point is on the unit circle? You think, well, I could draw it and go, well, where's that point? Somewhere about, be somewhere down here, I guess. I don't know. And so that seems like a weird thing. Well, all you have to do to verify it is you just have to make sure it fits into this formula. If it fits into that formula, then it is on the unit circle. So let's try it. I'm going to give you a 2-minute head start or so. And so we can pause the video right here. And you're going to try to see if those coordinates, that point, fits into the formula x squared plus y squared equals 1. Okay, so you can pause the video right here and we'll come right back in a minute. Okay, and we're back. And hopefully you found out that this was really simple and it worked. Okay, and so if I was going to do this and I start with the idea of x squared plus y squared equals 1, I'd say, well, x squared, that's square root of 7 over 4 plus y squared, which is -3/4 squared equals 1. Well, square root of 7 squared is going to be 7. 4 squared is 16. -3 squared is 9. 4 squared is 16. And 7 plus 9 is 16. And so you get 16 over 16, which is 1. And that's a true statement. 16 over 16 is 1. And so we have verified that this point is on the unit circle. Tonight on your homework, you're going to have to do this for 2 different points. And this is exactly what I'm expecting. I'm expecting that you would start with the formula and you would go ahead and plug it in and show that it is true. Okay, pretty simple. All right. Now, that was kind of on the edge of stuff we've done. Now it's time to talk about things that are nothing like what we have done. Okay, let's get all this. Okay, this is going to be something very different from what we've done before, and that's okay. All right, but we're going to talk about 4 things kind of all at the same time. First of all, we need to understand in algebra, the most common variable used is x. Everybody knows that. The most common variable in every equation, the most common variable is x. Well, in trigonometry, they decided to use a different variable. And so in trigonometry, we're using a Greek letter. Kind of looks like an Easter egg. Looks like that. Okay? And this is theta. Theta is the Greek letter that is the most common variable used in trigonometry. Typically, theta is the measure of some angle. That's typically the measure of an angle. Typically, that's what theta is, okay? So when we are using variables, I'm gonna start using theta today. You might see it in your book today. You will definitely see it more and more in the future. We'll still see variables like x and y and z and I and j and different variables, but the most common number 1 used variable is theta. And so we're gonna see that a lot. And theta is typically the measure of an angle, okay? So first thing, so that's a new concept number 2. All right, new concept number 2 is theta. All right, now, new concept number 3. Okay, new concept number 3 is an idea called standard position. Okay, and idea number 3 is called standard position. Standard position is how, from here on out, how we will think about angles. Every time you think about an angle, if I say it's in standard position, I'm being very specific about how it's set up, how it's located, okay, how it's positioned, okay? An angle in standard position is always basically kind of starts on the positive. Do you guys see that I have the X and Y messed up? I'm guessing I did that on all of them. Yeah, X and Y is messed up. Go up here. No, X and Y is right on that one. But I don't know if anybody caught that on this one right here. My X and my Y is backwards. I have no idea why that is. I'm really sorry. I guess it doesn't matter on a unit circle because it's a circle. But so sorry about that. But I just happened to look down and thought that is wrong. Okay, so this is the Y-axis and this is, of course, the X-axis. Okay, so standard position, the every angle will have 2 parts. Okay, every angle has 2 parts, and I want you to think about an angle almost like a windshield wiper. Okay, every angle has a part called the initial side, and it has a part called the terminal side. Initial side is where something starts, and terminal side is where it ends. Okay, and so for an angle in standard position, you can try to draw this, is what I'm saying is that the initial side is always on the positive x-axis, like that. That's the initial side of the angle. And the terminal side is somewhere else. It opens counterclockwise. So maybe the terminal side of the angle is right here, all right? And so I could look at that and say, well, this is the angle theta. And it looks like theta is about 60 degrees. Okay, so it started at the positive x-axis. It opened counterclockwise to that point right here. And so this right here would be the initial side. And this part right here would be the terminal side. Okay, so what is an angle in standard position? An angle in standard position is located on the coordinate plane so that the vertex, where's the vertex, is at the origin. Okay, you can see that. Vertex of an angle is the corner of an angle that's located at the origin. The initial side, which is where an angle starts, is on the positive x-axis. And the terminal side opens counterclockwise. There's a lot of words, and I'm really sorry that got so long. Counterclockwise. Okay, so here on out, every time we talk about an angle, almost always they're going to be dealing with standard position. And standard position is the initial side of the angle is on the positive x-axis, the vertex of the angle is at the origin, and the terminal side opens counterclockwise. Okay? And so that's what we're going to kind of look on here on out. All right. And so if I said, all right, I want you to go ahead and now draw a really quick coordinate plane, and I want you to graph an angle. Let's see here. We could say, let's graph the angle. We'll call it theta. Okay. Graph the angle theta, and we'll say that theta is 225 degrees. And I want you to graph the angle 225 degrees. All right, let's make sure you understand how simple this is. First of all, I'm going to draw a really basic x and y coordinate plane. And now 225. Well, I know it's, if it starts here at this positive x-axis, here to here is 90. Here to here is another 90, so now I'm up to 180. And to get to 225, I got to go 45 past that. So that's going to get me to right here. Okay, and that is going to be the angle 225. So if someone said graph the angle 225 in standard position, it would just look like that. That's pretty easy, okay? And a lot of times you don't really even make a big deal out of the initial side because we already have the x-axis kind of drawn right there and going in that direction, all right? Okay, now before we finish, there are, there are two more new ideas that we need to talk about. And it's kind of before we get to any of this. So we're not to this point yet, so I'm going to move this down a little bit. Let's see if we can get that down a little further. There we go. Okay, so there's two new ideas. All right. And first of all, what I want to do is I want to talk about the idea called co-terminal. Okay. Now the prefix co is like along with, a co-worker, someone you work along with, cooperate, to operate along with, things like that. Okay. So co-terminal is angles that share a terminal side. All right. So if I say, let's come up with an angle like theta, and theta is 60 degrees. And I want you to find a co-terminal angle to theta. Okay, now first let's finish. I started the definition. Co-terminal means angles that share a terminal side. And let's talk about what in the world that means. Angles that share a terminal side. Well, if I have an x and y coordinate plane, here's my x, here's my y, and I'm going to draw theta. We're saying, well, theta is at about 60 degrees. That's somewhere right about here. I'm not saying that's exact, but we're going to say, all right, that right there is theta. Well, how could another angle be located and have a terminal side at that exact same spot? Well, that's really easy. What you could do is you could go all the way around and end right there. So you could go one full revolution and then 60 more degrees. And so you think about, well, what would that be? Well, that would be 360, that's one whole revolution, plus 60 more degrees, which would give me 420 degrees. And this angle 420 degrees, would be co-terminal with theta. Okay, so to find a coterminal angle, you can always just add 360. If, like before, we had that angle theta, we said it was 225 degrees. A coterminal angle to that, you could add 360 and you would get 585. 585 is coterminal to 225. The other thing you can do is you can also subtract 360 degrees because you could always go the other way. You could go this, if this is the positive direction to go this way, then it's the negative direction to go this way. And so you could subtract 360 and come to here. And so if I had 60 degrees, I could subtract 360 and I would get negative 300. Okay, so negative 300 is also coterminal to 60 degrees. So how do you find a coterminal angle? You simply add or subtract 360 or any multiple of 360. You could add 360 and then add another 360. You could add 360, 360, and 360. You could, as long as you add or subtract a multiple of 360, you can find a coterminal angle. All right. Let's see here. Okay, we are almost done. The last thing that we got to talk about are 45-degree angles. Okay, we just got to talk about 45-degree angles. I don't know if you guys know this or not, but when you draw a 45-degree angle or when you look up at a 45-degree angle, a 45-degree angle goes up as much as it goes out. Okay? And so a 45-degree angle always goes up as much as it goes out. And so when you're thinking about a 45-degree angle or any points on a 45-degree angle, it's really easy to think about that because you could think about a series of points on the 45-degree angle. And this point right here could be the point 1, 1. Okay? This point right here could be 2, 2. This one right here could be 3, 3, or 4, 4. Okay, and so for a 45-degree angle set up in standard position, it's always going to pass through these points that have the same coordinate. So if someone said, well, 45 degrees, give me a point that this angle passes through, well, it passes through the point 1, 1, 2, 2, 3, 3, 4, 4, and so on. And someone said, well, what about a different 45-degree angle? What about 135? Okay, so 135, let's think about where that is. It takes 90 degrees to get to here, and it's another 45 to get back here. So it's really the 45-degree angle of the second quadrant. Well, again, that means it passes through all of these really common points, but instead of it being a point right here like 1, 1, it's negative 1, 1, okay? And negative 2, 2, and negative 3, 3. And you could do the same thing back here. This would be the angle 225. You could do the same thing out here. That'd be the angle 315. But the 45-degree angle of any quadrant always kind of has very similar coordinates. All right. One might be negative version of the other. They both might be negative. They both might be positive. But they'll always be the same absolute value. All right. Now, I know there's been a lot of information. We have one more example, and then I'm going to cut you loose. So here we go. Last example of the day. Example number 4. It says, if theta is 270 degrees, I want you to do these 4 things. I want you to draw the angle in standard position. I want you to name a point that's on the terminal side of the angle. I want you to find the distance from the origin to that point. And you also have to name a coterminal angle. Okay, this is actually way, way easier than you think. This might sound like a lot, but this is what a lot of your homework is going to look like tonight, and this is just too simple. Okay, it's really simple. So I'm going to draw a coordinate plane, x, y. Okay, so let's draw the angle in standard position. Okay, well, 270 starts, all angles in standard position start, I'll draw this one in red to make it show up a little bit. Okay, they all start on the positive x-axis. Okay, so we got 90 to get to there, 180 to get to there, 270 to get to there. So it's going to look like that. All right, theta is 270. So I could say 270. Check. Did the first one. Draw the angle in standard position. That part is easy. Next, name a point on the terminal side. Now remember, this one right here, this is the terminal side. Okay, so I have to name some point that's there, whether, any point that's here. Well, what are those points? All of those points are points that are on the negative y-axis. So they have 0 as an x value, and then they just have some negative number as a y value. So I could say, well, how about the point 0, -3? Like that one right there. Okay, all right, check. I named a point on the terminal side right here. All right, third, find the distance from the origin to that point. Well, that's easy enough. Find the distance from the origin to that point, okay? I know that distance, now we used r earlier, that r was equal to the square root of, I'm gonna say 0 minus 0 squared, because remember, the coordinates of the origin are 0, 0. So here's one of my points, and here's my other point. Plus 0 minus a -3 squared. All right, so what's that going to be? Well, 0 minus 0 is just 0 squared. 0 minus -3 is positive 3 squared. So that's going to be 0 squared plus 3 squared, which is 9, and the square root of 9 is 3. Okay? Check. The distance from the origin to my point is 3. And lastly, name a coterminal angle. Okay, if I have to come up with a coterminal angle, easiest thing I can do is add or subtract 360. So what I'd like you to do is right here, we would go ahead and add or subtract 360. So we're going to do that right here. We just add 360 and say, well, 270 plus 360 would give me 630 degrees. 630 degrees is coterminal to 270. All right, so you saw how I did it. What I'd like you to do is I'd like you to do this exact same thing. I want you to work through these same 4 steps, but I'm gonna give you a different angle, okay? I'm gonna go ahead and give you the angle, we'll say 180, all right? So for your last problem right now, we're gonna pause it for just a second, but what I'd like you to do for exemple numero 5 is I want you to say theta is 180 degrees, and I would like for you to do these same 4 steps. And we'll go through it in just a second. So we can pause the video right here. I want you to do those same 4 steps where you draw it, name a point, find the distance, and name a coterminal angle. Ready, set, go. Okay, and we're back. So we got to do the same 4 things, but this time we're going to do it with 180 degrees. Okay, so we'll bring this over here. There we go. All right, and we can probably get rid of just about all of this. There we go. Okay. So first thing I'm supposed to do is I'm supposed to draw it. Okay, so I'm gonna go ahead and draw my coordinate plane. Hopefully you did this first. Say, well, I'm gonna draw a coordinate plane. Doesn't have to be super fancy, doesn't have to be perfect. We're gonna get pretty good at drawing these real quick coordinate planes. And we say, all right, I gotta draw 180 degrees. Well, I know that it starts on the positive x-axis, and 180 degrees would go to right here, and it'd end on the negative y-axis, or a negative x-axis. Okay, and so that is 180 degrees. Check, did the first one. Second, name a point on the terminal side. Well, any point on the negative x-axis is just gonna have a negative x coordinate and 0 for a y coordinate. So you say, well, part B, any point on there could be like -4, 0, all right? So that would be a point on the terminal side of that angle. C, find the distance from the origin to that point. Remember that the origin is at 0, 0. So therefore the distance r is going to be equal to the square root of 0 minus a -4 plus 0 minus 0. And this is going to simplify down really easily. 0 minus a -4 is like 0 plus 4. So we get 4 squared. 0 minus 0 is 0 squared. Okay. So we get 4 squared is 16. So therefore R is 4. Easy. And lastly, we got to name a terminal angle. So the easiest way to name a terminal angle, add 360. So for part D, we can say, well, 180 plus 360 is going to give me 540 degrees. And this would be a co-terminal angle. All right. And that's all you had to do. So hopefully that all made sense and you're ready to rock and roll. So for your homework, what I'm going to have you do is I'm going to have you do some distance formula problems. I'm going to have you work some problems to prove or verify that some points are on the unit circle. And then lastly, I'm going to have you do some exactly like what we did just here with these 4 parts. All right. Have a great day and good luck.